I'm Adam Blattenberg from Diesel World.
Hi, this is Dan, owner of Dan's Diesel Performance.
I'm Christian Roth of BD Diesel.
I'm Braden Fleece, and you're listening to the Diesel Podcast.
What is going on, Diesel Nation? We're excited to have you guys with us today on the Diesel Podcast. There's a special giveaway we want to let you guys know about. Mishimoto is giving away a free diesel radiator. They've partnered with us and Turn 14 Distribution for this contest. It runs until February 28th at 11:59 p.m. Eastern. And to get entered, there's no purchase necessary. All you do is go to mishimoto.com/radiator giveaway. Or you can go to the Diesel Podcast on Instagram. And in our bio, we've got a link right to the contest. So you just go on there, enter some information, and a winner will be chosen. You'll be notified via email, and you can pick any radiator that you want for your diesel truck. So it's a great way to get ready for spring and summer and get an upgraded radiator in your truck and make sure when you're towing, hauling, doing anything you're going to do this spring or summer, you've got those temperatures under control. On today's episode, we've got Luke from S&S Diesel Motorsport. And we have gotten a steady stream of questions from people over the last 6 months, over the last year even. And people have been requesting, they want to know more about CP4s, if they've had a failure on their truck and they're thinking about upgrading, or a CP3 conversion. So we're going to chat with Luke about S&S, learn more about the company, more about his background in diesel. He's got an incredibly deep and really cool background that you guys are going to like hearing about. And then he's going to answer some questions about injection pumps and what you may want to consider if you're having an issue on your truck or you're looking to get some more capability out of it. All right, let's get to the podcast with Luke and chatting about injection pumps. Luke, welcome to the Diesel Podcast. I'm excited to have you on and be able to toss some questions your way that we've got from our audience about CP4s and newer diesel trucks and injection pumps. So we're excited to have you on today.
Yeah, thanks for having me.
This is the first time we've had S&S on the podcast, and it's always really cool to chat with a leader in the diesel industry. And for any of our new listeners out there, I wanted to start by having you tell us a bit about the company itself, its history, and what you do at S&S.
Sure. Yeah, so we specialize in common rail, modern electronic controlled fuel systems. So we're pretty focused on that. The fuel system is arguably the most important part of a modern diesel engine. It really kind of makes it or breaks it, and it really has allowed the diesel engines to get as powerful and as refined as they are. So that's really our focus and our experience and past knowledge is all in modern common rail diesel fuel systems. So that's high pressure pumps, injectors. We also do electronic controls for some of the competition race cars, whether that be with Bosch Motorsport systems or Motec systems. We do quite a bit of that type of stuff. So it's been a good time. We've been very fortunate, very busy. We got a good dealer base, a lot of good customers, and has seen a lot of growth here in the last few years. From a history perspective, we're a fairly new company overall, but pretty much all the background has been in the OE world. So originally the company started in 2012 timeframe, kind of early days. Andrew Stauffer and Greg Spoolstra both had experience with OE fuel systems. So Andrew, for example, has worked for Bosch for a lot of years doing new fuel system development, pretty much all around common rail, and for Bosch Motorsport as well, doing fuel systems and electronic controls, and then decided to do their own thing. And then here a few years ago, I'd been working for Cummins for 9 or 10 years doing new product development, engine development, and calibration work. I was in the combustion and performance and emissions group there doing new product development, engine platform stuff. And Greg was looking to slow down and retire, and I had worked with Andrew at Cummins. He was the Bosch on-site engineer, and I was the performance engineer, and we'd been working on a similar engine platform and kind of knew each other from there. So they started working on me to jump ship from Cummins and kind of jump in with Andrew and see what we could do with it. So we've kind of got some unique OE level background experience on product development and a good understanding of how engine systems work and how the common rail systems work, as well as the electronic controls that really make it all happen. So
I imagine that having worked at the OE level like that and then going to the aftermarket side, there's a tremendous amount of knowledge and expertise that you guys have that you're able to bring to, like today we're going to be talking about injection pumps, and be able to offer not just like a racing product, but also a product that somebody could use on a daily driver or a truck that, is a hotshot truck or something like that. Just the level of expertise and knowledge probably helps a ton when looking at these issues that may exist and people are looking for solutions to them, like with the CP4s.
Absolutely. Yeah. We're very fortunate to have had that kind of experience and had those opportunities with those companies, which if it wasn't for that, we wouldn't have nearly the experience or opportunity to know how things can go wrong and how things can go right. Until you work for a company that's mass producing things like that, you'd never dream that things could fail in the kind of ways that they fail.
Mm-hmm.
With that experience and with that background, you get a better feel for what kind of things you need to plan for, how things work, and how to design new products that don't have some of these failure modes or Achilles heel and things like that we might have found the hard way at some of the OEs. CP4s being an example of that.
Yeah, it leads right into a question we had gotten from a listener, and he said, hey, can you get S&S on the podcast and ask them about CP4 failures and what I can do to avoid one? I know it's a really big topic and there's a lot of angles to it, but for the guys out there that have LMLs or L5Ps or 6.7 Power Strokes or even some of the newer 6.7 Cummins, is what is the main issue and what do you guys offer in a way to be able to address, say, a premature failure or a catastrophic failure?
Sure. Yeah, the base design the CP3 pump was in production, 01 to current now, basically, for certain platforms. The CP4s went into production for the LML Duramax platform in 2011 and for the 6.7 Ford Power Stroke platform in 2011 as well. Probably the best bet, honestly, we've done because it is such a hot topic, there's a lot of those out there. I mean, there's millions of CP4 pumps in the world now, and there's a lot of guys that rely on their trucks every day who have these 2011 to 16 LML Duramaxes or 2011 to current Power Strokes or 2019 and 2020 Rams that rely on their trucks every day that are using these pumps. Because there's been so much interest in that, and also fairly high failure rates, we've focused some of our tech videos on that to try to help explain that, because it's easier to see than it is to hear, as far as some of that goes. So the guys that are interested in that or curious about it, I'd encourage you to go to our YouTube or Facebook pages, and we've got some videos on how CP4s work, how they fail and why they fail, as well as comparisons, CP3 to CP4, that kind of thing, and in conjunction with how some of our products work. But in a nutshell, the bottom end base design is significantly different in the CP4 than previous generation. And there's the CP4 uses a really aggressive 2-lobe cam with pumping elements that use a roll on the bottom. And the trouble is, in some of those cases where these are failing, the roller skids, either seizes and skids or just skids in general on the cam, and then creates an aggressive metal-to-metal contact that starts to generate a lot of heat and then generate debris and then start to fail catastrophically. The other thing that can happen is the roller will turn 90 degrees on the cam, and at that point, when the roller turns 90 degrees, there's no saving it at that point. The roller just doesn't roll anymore because it's 90 degrees from where it's supposed to be. So there's a decent amount of them that fail that way. And there's, like I say, that one's a tough one because there's no saving it at that point. And the real Achilles heel of a CP4, if just a pump fails, pump fails. That sucks, but that happens sometimes, right? If a component fails, okay, replace that component. The real damaging part of the CP4 design is the bottom end of the pump feeds to the high pressure circuit. So when the pump fails, it generates a lot of metal debris, and instead of it just containing its own metal debris and failing, it actually contaminates the whole rest of the system. and the whole rest of the system is very sensitive to metal debris. So it's really a lose-lose in that case. Not only did you lose a fairly expensive high-pressure pump, but now you wiped out a real expensive set of injectors and rails, and you got metal debris in the tank and on all your lines, and it's a disaster.
Now, as far as the pump itself, is there a way to, a lot of the questions that we got from Instagram were, hey, is there a CP3 conversion kit for my truck? Or is that the option? Is that the best solution, is to just get rid of the pump entirely? Or are there ways that a CP4 can be built or upgraded where you can eliminate much of the risk with what you just described with failures?
Yeah, the preferred solution is a CP3 conversion, because that's a tried and true base design that really is just a bulletproof. So wherever possible, our preferred approach and where we have developed products is around just converting it to a pump that you've got confidence in, that's a lot more reliable and robust. There are some advantages to the CP4, I'll say. It's not all bad. Technically, the high pressure side of it is capable of high pressure, and it's much more modular, it's lighter. I'm sure it's easier and much cheaper to manufacture. There's all those other factors, but from a reliability perspective, it just doesn't have it. So maybe for the OEs, they made the decision based on millions of trucks of volume, when it came to a weight or a packaging or a cost perspective. But in the aftermarket, when guys really care and can afford to spend a little more money on their truck, especially if it's something they really rely on, then that's where the CP3 conversions really come in. So we'll do, say for the LML platform, a really popular product of ours is a CP3 conversion for the LML platform. Actually one of the most popular ones is a straight drop-in, no tuning required. Like the truck doesn't know any different. Nothing really even knows any different. You literally just replace the CP4 with a much better CP3, and we've built the pump to match the flow curves of the CP4, so you don't even have to do any tuning. And it's even got a ninth injector dosing line to interact or to interface with the emission system. So it's a CARB compliant, emissions tested solution that just really gets a guy to a much more reliable solution. But it really depends on the platform on whether or not you can do that. The CP, I know, like we get a lot of guys asking about the 6.7 Ford platform, and unfortunately, just because of the design of the block, of the engine block itself, a CP3 won't fit in the valley there. And we've tested with a lot of different scenarios of different base pumps and different modifications and different things, and it's just space constrained there, unfortunately.
That was one of the questions we got, was about 6.7 power strokes and a CP3 conversion.
Yep. So we've got some stuff in the works. Historically, we've for whatever reason, I don't know if it's because Andrew's always kind of been a Duramax guy and I've always kind of been a Cummins guy. We've kind of always focused on the Duramax and Cummins platforms, but there's a huge market with the Ford guys. I mean, I drive a Ford currently, and that's a development truck for us, and so we've got a lot of good stuff coming for the Ford guys. We've kind of left them lacking the last few years, I'll say, in some cases, but that's a key focus area for us. So I can't say too much about some of the neat stuff we've got in the works because it's a little early and don't want to let too much out, but we've certainly got a lot of good products coming for the Ford, and specifically related around fuel pump development. So should be exciting stuff.
You'd mentioned as far as CARB compliance or testing. I wanted to ask you about that because a lot of people are interested in products for newer trucks that they can run to either address, an issue like a CP4 and its failures or other factors in it, but they want to make sure that, if they live in California or they drive through it or they drive to another state or whatever it may be, that it's something they can have confidence in. And I wanted to ask you a little bit about the testing process and the products you have. And it seems like a focus as well that you guys have had with getting a 50-state tested product out there for truck owners.
Yep. Yeah, I guess I'd say we were probably kind of one of the front runners earlier on with getting some of those products. Used to be there wasn't nearly as much focus on a lot of that, right? Just because the enforcement, the environment around some of the enforcement on aftermarket products wasn't nearly where it is now. But we were kind of one of the earlier adopters of getting some of that done. Working with CARB, the California Air Resource Board, and SEMA, and getting emissions testing done and getting submittals where you say, hey, here's the product we're developing, here's the advantages to it, here's how it's not going to be detrimental to the function of the rest of the systems in the vehicle, and that kind of thing. It's more work, it's more cost, and it's more difficult to develop products that are not detrimental, but it's the right thing to do, and it's the safer thing to do in the long-term game. So we do a little bit of everything. We do a lot of racing stuff. We've got, diesel drag racing has certainly become more popular. We're doing a lot of the ultra-high performance stuff like that, but really a lot of the volume and a lot of what the everyday customers need is just better products that they can use in their everyday trucks that are safe and legal to use. So that's where, we've got a lot of development going different angles, but we're certainly putting more focus on getting more of these products out that solve everyday solutions, everyday problems. Not everybody's wanting 1,000 horsepower, 2,000 horsepower, or whatever vehicle. The vast majority of people just want to have a nice, functional but fun at the same time and reliable vehicle.
I remember seeing when you guys had released the 50 state products. It was, at least when I saw it, it was like a time where I think that a diesel enthusiast would look at the newer trucks in the aftermarket and they would say, well, we're just stuck with what the OEMs gave us. And there's no solution out there. There's no option. I'm just going to have, a 100,000 mile truck now instead of a 300,000 or 400,000 mile truck like I used to have. But when you guys started to release these products, it was really refreshing and inspiring to see, hey, we can keep this truck in its emissions configuration, but have a much better product so you don't have to worry about metal in your injector lines and injectors and fuel tank and everything else. And I think it sort of spurred on the whole industry in a way to say, okay, well, what can we do with turbos? What can we do with this? What can we do with all these other components to be able to still meet that emissions requirement, but give people what they wanted for either performance or a little bit more power or just efficiency.
Yep, exactly. Yeah, there's certainly, the game is changing. It has changed, and it certainly is changing, and it's getting more difficult, but we kind of like that challenge, and it kind of plays into our hand a little better in general, just because that's kind of our background is doing it the way, essentially what is the trend of where things are going is they're starting to apply some of the regulations and some of the rules to the aftermarket that have applied to the OEs for years. So, there is a ton of regulation around the OEs and, all kinds of documentation and emissions compliance and all that kind of stuff. And basically where some of that stuff is going is applying similar regulations or similar thoughts to some of the aftermarket products, which hasn't really historically been the case. So it certainly is changing the market, but those who can adapt will. And so that kind of plays into our hand a little better anyways, because we know what it takes from the OE side, because they've had to deal with all that for a long time. And then we can apply that to the aftermarket side and give the customers good products in the aftermarket that are maybe a little more challenging than it used to be in the old days, but still really good products that people are happy with and need for their street trucks.
Well, yeah, I mean, exactly. It's something that, in the past, I would agree it wasn't historically part of what the aftermarket was. It was, okay, here's a platform, what we're given. We know it needs air and fuel and timing and other things, and you're on your way. But these newer trucks make more horsepower, more torque than they've ever made. definitely more than second gen 12 valves or early common rails made. And so just from the outside looking in at what the big three are making, it's like, okay, I've got more power, more torque, better transmissions, more technology, and it's being done under these constraints of federal emission standards. And so to be able to see that knowledge and history and experience now be applied to the aftermarket, it raises the bar to a level that I know inspires a lot of people out there, as far as being enthusiasts, keeping their trucks for a while, not being hesitant to get, this new truck or this particular year range truck, and to be able to use it how they want. So I know the whole industry is really excited about that.
Yeah, and things have come a long ways. Unfortunately, some of the earlier after treatment systems, everybody was learning, right? The suppliers were learning, the engine manufacturers were learning, the vehicle manufacturers were learning, and so there historically had been some issues with some of the DPF and SCR systems and all that kind of stuff, and EGR and all that. But a lot of that's come a long ways. Everybody's learning constantly and getting better, and it's kind of a catch-22. I remember even when I was at Cummins, a lot of times you'd want to, because it's so difficult, you'd want to complain about some of the regulations and that kind of stuff, because there's so many hoops to jump through and everything's so challenging. You got to run all these different tests, and everything's got to be just absolutely perfect. But if you actually take a step back and look at the big picture, the only reason I had a job, Cummins, was because of emissions regulations, and because that stuff was difficult, they were employing all kinds of engineers to be able to develop new products. And if it wasn't for some of the emission standards, we wouldn't have all the cool stuff we have right now. So yeah, there's a lot of regulation, and in some cases there's a lot of overreach, and there's some of that kind of stuff going on. But if it wasn't for emissions regs changing every few years, we would never develop all these cool new technologies. And so we have higher pressure capable fuel systems now than we've ever had before that can do all kinds of cool stuff, but there was no need for that if it wasn't for needing to make the trucks more efficient and needing to make them lower particulate output and needing to make them, more capable in a lot of these ways. So if you look at engine development over time, it really trends with regulations over time. We'd still have the same old loud, smoky, underpowered mechanical injected engines if it wasn't for a lot of the standards changing. So it's obviously there's pros and cons both ways, but forcing some of that development isn't necessarily a bad thing. Sure, it can be problematic when it affects companies negatively and things like that, but it sure has driven a lot of engine development in a pretty short period of time.
Yeah, it seems really quick, and I think combining the experience that you had just mentioned at that OEM level with the aftermarket definitely is going to create an exciting atmosphere for products. And before we had done the podcast, I said, hey, I'm going to post up on Instagram, and I'm going to ask our listeners, what should we ask S&S? And so I've got a handful of questions. Some of them we've touched on a little bit, but these are direct from our listeners, so I'm just going to read them off to you. But I wanted to get your opinion on some of the things that our listeners are wanting to know. And let's start with this first one here. Is this listener had asked, what kind of info do they have on 17 to 19 L5P emissions CP3 conversions?
Sure. We've the L5P platform went to a different fuel system, in 2017, which is actually Denso based versus Bosch. Uses a fuel pump called an HP4 that is a different design. It's not a bad pump, but it's not. It doesn't perform as well as a CP3, and it's not as robust as a CP3. But we have developed CP3 conversions for the L5P platform, and we're actually in the process of developing more right now. And we've actually got a 2020 L5P Duramax engine here right now from our friends at Sterling Diesel in Texas. Had one out of a truck, and there was some changes in the later generation L5Ps versus earlier's relative to how a pump can fit and mount and things like that. So we're putting some final touches on some of the L5P CP3s. But guys will be hearing more here in the near future relative to that platform. We're going to be offering more of those options, as well as looking into, it's a completely different animal with that fuel pump, but we're also pursuing doing similar as to what we've done for other platforms, where you get a no tuning required option, where it's basically a straight drop in and you just get a better pump and you're on your way.
Is that a lot of requests that you get from dealers and customers, is to have a no tuning option with these conversions?
It's something that is it's not necessarily surprising, but it had been. We were the only one. We're the only company that was really doing that, just because of the ability to modify the pumps in such a way to make them a drop-in and not have to require tuning. But with more and more challenges all the time with tuning, and with some guys not actually wanting to have a tuned truck, they just want a more reliable truck, it's certainly a really popular option. Because, say the no tuning required option is a few $100 more, well, they're going to spend a few $100 on tuning most likely to be able to, properly run the other version. And if they weren't planning on making any other changes that they needed for tuning, then it just makes sense to do a hardware-only change and not have to do a hardware and calibration change. So it's become more and more popular, especially with guys that don't want to have to go through a few revisions of tuning and data logs and stuff like that. They just want to throw, say somebody's got an LML and they had a CP4 fail, and they don't want that to happen again. They just put a CP3 in it, and they want to be in and out. A truck shop's got that truck scheduled for however many hours that day, and they don't want to have to mess with tuning it or having to do data logs. They can literally just put hardware on. Then that's where the no tuning required options of ours, whether it be for an LML CP3 or a 2019, 2020 Ram CP3, that's where those are a great solution.
That actually perfectly leads into the next question we got, and that was about info on 6.7 Cummins CP3 conversions and what you guys have for them.
Yep. So we developed the 2019 Ram, the 2019 6.7 Cummins, which actually that engine is built in a plant just not far up the road from where we're at. We're kind of here in Cummins country, but this 2019 Ram engine was a pretty significant redesign. CGI block, hydraulic lifters, went with a different fuel system. There's a lot of different changes to handle there again, we go to engines are constantly developing, and the stupid thing's 1,000 foot-pounds of torque from the factory now, something that would have been unheard of. But they went with a CP4-based high-pressure pump. And as soon as we saw that was happening, we actually bought a engine out of a brand new 750-mile engine out of a wrecked truck. I don't know, a year and a half or so ago, was probably one of the first ones around to do some development with. And so we started off right away knowing we wanted to do a CP3 conversion for it. So it's a little more challenging in that case just because of some specifics around that. That pump is actually driven 1.5 to 1. So the pump is 50% faster PM than what the engine is. So with that being the case, we actually do our CP3 build different than just a normal CP3. We actually have some features and some hardware that perform better at high speed and are more reliable at high speed. So, because when that pump's got 100,000 miles, or when that engine has 100,000 miles on it, that pump's got the equivalent of 150,000 miles on it worth of revolution. So that's unique to the 19 and 20 Ram.
Well, it's probably also challenging as well with, I guess, I'm not sure on what particular model year, but their newest trucks going back to a CP3 injection pump as well. So it seems like it's going to be a limited year range of that particular pump in a 6.7 Cummins.
Yep. Yeah. So they launched it for the 19 model year and 20 model year. And I don't know exactly where the cutoff was, but shortly after launch, I think they realized that they were having failures and warranties that they shouldn't have, and immediately were kind of pivoting and backtracking to go back to a CP3 pump. So I'm actually, but from Andrew and I would never guessed that it would happen as quick as it did. Both of us working at Cummins and Bosch, it takes forever to do about anything just because of big company stuff, but they actually pivoted pretty quick and got back to a CP3 pump for 2021 model years. So it cut into the obviously the available vehicles from our perspective, but they did the right thing in going back to a more reliable pump. But we end up doing a decent amount of work for some of the OEs as well. So we've been doing actually some contract work, helping some OEs with failure analysis and testing and things like that on a variety of fuel pumps.
Our next question, this is interesting. This listener wanted to know if you guys have any products in the pipeline for the 2.8 and 3.0 Duramax.
We've done some 2.8 and 3.0 stuff already as far as injectors and things go. In general, we can work with about any Conrail injector, whether that be small stuff like the 2.8 up to all the way up to 60-liter V16 type of things. So we don't necessarily have anything on the price list for those platforms. I'd expect us to have some more products for those in the future. And like I say, we can and have done some injectors for customers, but it's not something we have on the shelf just because it's newer platforms and lower production volumes. We kind of have to focus some of our development where it makes sense first. But we're growing the team and hiring more people and going to be able to do some more development. So I'd expect to see some growth in more of those other engine platforms.
This next question, we head back to the 6.7 Cummins stuff, is this guy had asked, what's the deal with the new pressure relief valve on the 19 Plus Ram?
Okay. So like I mentioned, some of these newer platforms, a lot because of the emission standards, power requirements, and all kinds of customer requirements for noise and drivability and stuff. All these fuel systems are going towards higher pressure capable injectors and fuel systems. So the relief valves on these newer platforms, and the 19 Ram was the first one for the Cummins, but actually it's been that way since 2011 for Duramax and Ford, have what is called a DRV, which is an electronic relief valve on the rail. So it looks really odd if you're used to seeing the old mechanical style relief valve. It was basically just literally a pop-off relief valve. The electronic relief valve allows them to use it, not only just use the pump to control rail pressure, but now you've got control of the in valve and the out valve to the system, basically. So they're able to control the pump of the flow in, and they're able to control the DRV for some excess flow out. So it can trim overshoots and work as a traditional relief valve, but also it can help to control pressure more effectively. In a lot of cases, at idle especially, because these trucks are also quiet now, they'll actually have the pump be far more open and further more flow than what they really need. And then they'll use the electronic relief valve to bleed off the extra. And that's because the high pressure pumps are often pretty loud when they're mostly closed, just a function of how the pump operates. So to control noise, they'll actually put more load on the pump and then bleed it off with that electronic relief valve at idle. But it does help to really the injectors, the generation injectors don't have much leakage in them at all. Used to be you'd have quite a bit of leakage back to the tank, but the new injectors are so much better and higher pressure capability and less leakage that in some cases they actually trap pressure for a long time too. You can shut the truck off and you'll still have a lot of pressure in the system where it used to have leaked off. Well, now that electronic relief valve dumps the pressure in the system when you shut it off. So it's more capable and you got more flexibility, but it's also kind of a safety feature.
Is it really, probably oversimplifying it, but is it really built around those emission regulations and how precise the OEMs are needing to be with rail pressure and particulate matter that things like an electronic relief valve come into play?
The emissions regulations and some of the power requirements and things like that have really driven every generation has needed to be higher and higher pressure, like rail pressure, injection pressure capable. And so, like say for example, the LB7 and the 5.9 were a 1600 bar system, and then next generation was 1800 bar, and then like LML was 2000 bar, and So every generation, now we're at like 2,500 bar capable systems. And so every generation gets higher and higher pressure capable. And usually that's because either you need to be able to inject more fuel in a shorter window, or in a lot of cases, that higher pressure capability helps to reduce particulate matter, helps to reduce smoke. Usually higher rail pressure also helps with efficiency. So there's always kind of a trend of NOx output versus particulate and versus fuel economy, but the aftertreatment systems actually help clean up a lot of that. So it doesn't have to all be perfect in the cylinder anymore. You can actually let it be higher NOx in the engine, which is more efficient, and then clean it up with the SCR downstream. So the higher pressure systems really help to enable better precision, like you mentioned. Actually, a lot of these cases, these things are multiple injection events per cycle, so it could have multiple small pilot injections, one main and post injection and all that kind of stuff. So they've got all kinds of levers now that we never used to have. When you had a single injection mechanical type of thing, it's noisy, it's not as efficient, it's got higher emissions output, all that kind of stuff. But now the systems are so advanced that it'll do whatever you want it to do.
This last question, I had to pick this one because I think as a diesel enthusiast, we all love the racetrack and things going fast. But this listener had asked 14 millimeter stroker CP3 horsepower limit. Now, he didn't specify if it was for a Duramax or a Cummins, but if you could touch a little bit, say, on both, or what kind of application a 14 millimeter stroker would be recommended for.
Yep. The 14 is a popular one, especially with a lot of the race guys and sled pull guys and stuff like that. It's kind of a tricky question because it's a full system, of course, and the pump can deliver, however much, a certain amount of flow, and then it's really up to the engine to make the most amount of power with that kind of flow. So, we see a significant amount of power out of single pump applications, and we've done, dyno testing on. Actually, we were doing some Duramax testing with Wagler Street Engine platform, just stepping up injector and pump sizes and turbos and going up and up and up. But it really depends on the full system. As boring as it sounds, it's literally a fuel economy, a fuel efficiency thing at that point. The OEs measure fuel economy in pounds of fuel per horsepower hour, and that's basically what it comes down to. The pump's going to deliver a certain amount of fuel flow, but depending on whether you got a Duramax or a Cummins and what your tuning is and what turbo you've got and all that kind of stuff is going to affect how much horsepower you make with X amount of fuel. I guess a perfect example actually is sled pulling versus drag racing. Drag racing, we can make far more horsepower with a single pump or a pair or triples of certain pumps than you can on sled pulling, typically because the sled pulling classes are air limited classes. So say that's a 3.0 charger, so that means the inducer on the compressor is 3-inch. Well, the thing's sucking through a straw basically, so it takes far more fuel to make the power because you don't have as much oxygen and they're typically fairly inefficient. But a drag race vehicle with a big turbo and lots of nitrous has got tons of oxygen on tap, and they're really efficient. So you can make, for example, like a lot of these drag cars are 2,500 horsepower, 2,600 horsepower, and 212s is all they need, and they still have extra on tap. But 212s would barely make half that in a pulling truck. So it really depends on the whole system. The whole key is make the whole system as efficient as possible.
So really, if somebody has questions about that, it's probably best that they call you guys and chat about their application and what they got going on, because there's so many variables in it.
There are certainly a lot of variables, and I'm hesitant to throw a number at it because you see that stuff on the online a lot where they say, I made X amount of horsepower with a single this, that, or the other. And people tend to, because you always want to simplify things because it's too hard to actually consider all the factors, people tend to latch onto a number and say an S&S pump is worth X amount of horsepower and whoever's pump is worth Y amount of horsepower. And, you really just need to look at the data sheets on the pumps, and that'll tell you how much pump flow there is, and then it's up to you to make horsepower with the pump flow that we give you. So that's why we send data sheets with every pump that we build, all the tuning required stuff anyways, but any of our competition pumps, there's data sheets in there that show exactly what their fuel flow is, and then it's up to them to make the power with the fuel delivered.
Well, this was a really informative podcast. There's a lot of just new things that are happening in the aftermarket and advancements that, even like doing podcasts every week, it's tough to stay on top of everything that's happening. And so when we got a lot of these questions, I'm like, I need to learn more about this pressure relief system on the 19 plus Cummins, or what is coming out. Why can't you put a CP3 on a 6.7 Power Stroke and these other things? So I appreciate you taking time out of your day to chat with us, to answer these, and then also give us some insights into really what goes into development and what you guys are doing at S&S to be able to, I think, merge the precision and the expertise and the knowledge of working, at at this OEM level, and be able to take those processes and apply them to the aftermarket, which is something that's so important. I think it's going to be crucial to the future of diesel, not just maintenance and repair, but performance, is to be able to have those advancements within a framework that's given, which, Cummins and Ford and Duramax and GM, they've been doing that for almost 2 decades now, but the aftermarket wasn't historically like that. So it's really exciting to be able to see that merge into the aftermarket now.
Yeah, things are certainly changing, and it is becoming more difficult, more challenging. Like I mentioned, I think that really it plays to our strengths well, in that we can adapt and we can develop the more difficult products and do the testing and things that we need to do in validation, but we're usually just looking for where there's needs in the market for new products, or we know that there's failures and we want to remedy those failures for customers, or we know that there's potential for failure in certain ways, and how can we make that better, or how can we improve our existing products. One example of that is the most popular product for the 6.7 Ford platform is our CP4 bypass kit, which if the pump, it basically isolates the pump essentially. So if the pump fails, it doesn't allow it to contaminate the injectors and cause other catastrophic damage to the system. It really just isolates it and reduces the amount of damage that it causes. So that's a really popular one. And knowing, we've had that in production for a few years, and knowing that we're always trying to continually improve things here for the last, year or so, really, we've been working on a Gen 2 version of that. And so we're excited about it. We're going to be releasing that here real soon. But we've had that in the works for a long time, just kind of in the background, continually improve on it. And it's going to be a better system, easier to install, better protection. It's got a return side filter to catch all the debris before it goes to the tank, so a guy doesn't have to drop the tank and clean all lines and everything like that. So we're just always kind of looking for ways to do things better, needs in the market that exist. And honestly, we're a small company. We're lean and mean, and we're growing in lots of ways. But actually, we get a lot of the development kind of comes from our customers. So we're busy with our current production stuff, and we're doing new development. But there's a lot of cases where people are coming to us and saying, "Hey, can you do this or that?" And or there's a need for this. Can you guys develop something for that market? And that certainly helps. We always have a lot of voices trying to pull us different ways, and sometimes it's the niche markets that are the loudest, but they don't actually pencil out. There's not many of them out there for that market, but we've been doing a lot of stuff for overseas customers as well. For some reason, a lot of I don't know exactly how they find us, but a lot of guys in Australia, a lot of guys in Europe, a lot of guys different parts of the world have been sending stuff our way. So it's been good, and actually we do a decent amount of OE testing too, since we've got a lot of the equipment capability and technicians and knowledge and stuff. A lot of times some of these big companies, the Cummins and GMs and and PACCARs and some of these big companies, they actually come to us to help them with testing and validation and troubleshooting and teardowns and stuff like that, because we can do things a lot quicker and usually more cost effective than sending stuff to Europe or Japan or whatever else.
It's really exciting to hear that and see, like, diesel just, the future's bright with it. It's just there's that learning curve, and sometimes we don't want to wait for stuff. But as you'd mentioned earlier in the podcast, like, you think back to like 2008 or 9 or 10 and just how the trucks performed or what issues they had versus 2020 or 2021. It's an entirely different ball game with just reliability and efficiency and power and torque. And so I know that we're all looking forward to seeing what you guys crank out this year, and I know you guys are busy, and I appreciate you taking time out of your day to chat with us, answer these questions, give us some insights, and like I said, we look forward to seeing what you guys bring to the diesel aftermarket.
Thank you. Appreciate it. Thanks for doing your part to keep the industry informed and pushing it.
Don't forget, diesel fans, make sure and head on over to Mishimoto.com/radiator giveaway, or search the Diesel Podcast on Instagram. And in our bio, we've got a link to get entered for the free giveaway. So you just go on that the website, fill out a short, just some short information, and the contest runs until February 28th at 11:59 p.m. Eastern, and a winner will be chosen after that. You'll be notified via email, and you can pick the radiator that you'd like for your diesel truck. Until next time, keep the shiny side up.